This is A Voice, a podcast with Dr. Gillian Kayes and Jeremy Fisher.
This is A Voice.
Hello and welcome to the podcast. And this is a very special edition because we're having our first guest in our Lockdown Heroes series. And this is all based around SOVT, and Oren Boda, who's our SOVT expert, is going to be telling you what it's all about.
And you know what? This is podcast number 10.
Number 10.
Yeah, amazing that we got there. I just want to say something about why even the idea of lockdown heroes came about. You know, there's some really heroic stories that we've been hearing about within our voice community. And, you know, how people have navigated moving from in-person singing lessons around the tech of working online, and particularly how people who run their own theatre companies have been working, you know, sort of youth companies, and people who work with choirs wanting to still be there for their communities. And it's been an enormous challenge, and just watching people navigate that has frankly been inspiring.
I think one of the great things about working in music or working with the human being actually is how creative you can be. And we have watched people really grab the creative thing and go with it.
And I think as well, musicians are collaborators. You know, most of the time we're not doing this performing thing on our own. And I think that one of the reasons why people have been able to move on at this time is because they've been talking together.
Yes.
They've been collaborating.
Yeah.
And that actually brings me to more or less how we got to meet Oren.
Yes.
Which was through our informal Let's Talk kind of networking and brainstorming sessions that we had been running in person in London every so often. And that's really where we got to know Oren.
Yeah.
So I want to do a little lead into Oren here. Those of you who are watching on YouTube, I don't know how well you can see here, there are many, many straws here.
Gillian is holding up a glass full of straws.
And this one, which is quite a classic as well.
This is the Dr. Vox.
The Dr. Vox.
We'll put a link to the Dr. Vox
How about
in
this
the show
one?
notes. And this is the mask.
Which we might hear more about later.
Yes. That wasn't me putting my hand over Gillian's mouth. That was her putting the mask on.
Okay, so now as we hand over to Oren, something I wanted to say was, first of all, of course, we got the Obi-Wan Mark 1.
That's the straw.
This is Obi-Wan Mark 2, and I have to confess, Oren, as you come in, I didn't quite know how to unpack it. I got myself in a right mess. I took this off.
And then couldn't work out how to blow down it.
No, I had a lot of trouble. I actually didn't realise that this wonderful thing was in there. I think I was trying to blow through it.
Yeah.
Which didn't work.
Because the
quite.
wonderful thing that Gillian is talking about is that I love this. This is one of my favourite bits actually, which is an extendable brush to clean the inside of your metal straw. Love that.
So shall we bring him in?
Go on then, let's bring him in. Hello, Oren.
Thank you for being our first guest.
Hey, thank you for having me. This is really exciting.
Welcome to the podcast.
So, how should we start? I mean,
Well, Oren, how did you start?
Yeah.
Because, I mean, weren't you originally a psychology student?
I was, yes. Actually, even before that, my story is just this wacky story of indecision, I suppose. So even before psychology, I was set to go to uni and study graphic design. And I got to the open day for that. I literally took one look and I was like, I can basically do all of this stuff already on Photoshop and I don't really understand why I'm here.
Yeah.
And so I kind of went back and I revisited and I was like, okay, right. I'm going to have a serious think about what I want to do with my life. And it took me down the psychology route. And so I went to uni and I studied psychology, neuropsychology and music in particular, looking at ways to improve people's musical ability using novel new brain stimulation techniques. So yeah, that's kind of how I got started.
So you were already doing music before you went to uni, but how were you doing music? What were you doing
before uni? So from the age of like 14, I was at just a local theatre group. They were just a local school, and it was more towards drama. And then one day they were like, okay, it's our show coming up. They had this sort of elaborate thing planned, and they didn't have any specifically tall males to fill a role, and I was the only one. And they were like, well, you've just got to do it. And I was like, no, I'm not a singer, I don't sing. I'll do all the acting stuff, that's cool. I'm not going to do dancing, certainly, and I'm definitely not singing. Anyway, they convinced me, and it was so much fun, and I was hooked, and I was like, okay, right, I want to explore this more. And so that evolved my pathway through singing, basically.
Excellent.
Well, I'm just interested because I didn't know you'd studied neuropsychology. I knew you'd studied psychology. What attracted you especially to the neuro side of it?
It was a function more of what I wanted to do research-wise, because I knew I wanted to do something in terms of stimulating people's brains to see if we can find ways to improve musical ability. In general, it's kind of any learning task, but the focus at that time was musical ability. And I knew it was a component that I needed to understand in order to fulfill that requirement of my thesis. So that's kind of why I went down that route as opposed to just being generalized.
Okay, and I remember a couple of things that when we had our very first Let's Talk meeting, that I was really struck by you saying that because of the research you'd done, the reason why you were involved in music was because of the impact of music on the brain and how it improves neural function.
Yeah.
Do you want to say a bit more about that, what you found out from your research?
Yeah, so the study that I was doing was using novel new brain stimulation techniques. They're typically called on the internet binaural beats, and it's basically two tones presented to one tone to one ear, one tone to the other ear, and the difference between those tones are in accordance to a brain frequency, a brainwave frequency. And the research that I was doing then was, how can I use these techniques to see if we can improve the learning of a novel melody task. And what we did, we created a study in which the person was presented with either a alpha wave frequency, beta, or a sham frequency, and they had to go through kind of like a matrix table after listening to a novel melody and try and reconstruct that melody without any knowledge of music. They literally just had to like listen to pitches and select the right ones in order. And the data that we got back was very much in favor of alpha frequency being a significant factor in increasing people's ability to both recall and recreate this novel melody, as compared to beta and sham. Beta and sham were relatively similar. There was a slight improvement in beta, but there was a significant improvement in alpha, which was pretty cool, especially as an undergrad.
Well, I was just about to say, you are describing something that is not a typical undergrad level thesis, really, is it? I mean, that's...
It's not, no. I had to fight for it. Typically the way it worked was you go to a supervisor, and your supervisor has like a set list of topics and projects that you can work on in collaboration with other psychologists and other students. And I kind of looked at it and I was like, I don't really find any of these particularly interesting. Can I do something else? And I sort of had to prove that I was capable and committed to doing it before they would let me. And they did. And it was, I think, one of the most fun projects I have done in terms of learning experience. Yeah, it was really cool.
That's so interesting. So it seems that you're probably a natural researcher, and as a psychology student you would have had to do some stats as well. So you're kind of well prepared for where you went next.
So where did you go next?
Yeah, where did you go next?
So down the singing route, and specifically towards straw phonation and SOVT.
First of all, Doran, tell us what SOVT actually stands for.
Just for those who don't know.
Sure. So semi-occluded vocal tract. So in essence, you know, the bit that you're talking out of your mouth space is your unoccluded vocal tract, essentially. If you put anything in the way of that to reduce that spacing, then you occlude it partially, and so it's just a reduction of the aperture in some way at any point along the vocal tract.
Great.
Thank you. User-friendly
so-
scientific explanation.
Yeah.
Thank you.
Yeah, we're good at that too.
So yeah, it was basically I was in a lesson with my coach, and I was working. I think, and I've quoted this before, so I'm going to stick to it. But I'm like 90% certain it was this song, Prayer, and I just couldn't get the high notes, and I was like, this ain't happening. Let's look at something else. I'm kind of fed up with this. And the coach that I was working with at the time was like, no, we're going to get it. Let's just see what things we have available to us to help us. And then he gave me a straw, and I kind of looked at him like, I don't need a drink right now. Like, what's going on? And obviously he kind of explained what it was about. I was really skeptical, and he was like, look, let's just try it. Let's just see what happens. And we played about a bit, and I did it, and I got the notes with straw phonation. And I guess from then I was just hooked, and I just, coming from the background and kind of the mindset I had, I needed to understand and know why that was a thing that worked. And then obviously that spiraled into this crazy rabbit hole of science and research and stuff. And that's kind of where I've ended up now.
Because the straw that you first developed, that was in development even when we were doing our first Let's Talk.
Yes.
Because it was one of the things you talked about. I mean, one of the things that we encourage in the Let's Talk is for people to bring their plans, and then we can discuss the plans and help people move on. And then, of course, lockdown happened.
So you'd,
Yes.
I mean, first of all, you'd already gone into manufacture, and I think it might be interesting to hear about how you dealt with the whole manufacturing thing.
Yeah.
And then we can talk about what happened with lockdown, because you were already in production and sales, weren't you, when lockdown happened?
Yeah, so what happened was I started selling the version 1 in 2019. I think like late August 2019. And I almost sort of 2 months into that, I was getting a lot of really good feedback, a lot of good data from the people that were using them, and lots of things for improvement. And so I pretty much straight away went into like prototyping mode and just sort of rapidly engineered some improvements. As of sort of late November, I updated our schematics and our technical drawings with our manufacturing partner, and we were supposed to start manufacturing in December, ready for a sort of early February release. Then obviously the region of the world that we get things manufactured in started experiencing significant problems with COVID. And then as a result of that, the factory just shut down, and it was closed. Well, it reopened with a skeleton crew in late February, and that crew, basically half of our stuff was like complete, half was raw material, so everything we use is stainless steel 304, so it's food grade, and it has to go through a very particular process in order to prepare it for manufacturing. And so we just had like raw materials sat there, we had like half completed units sat there, and everything was kind of just a bit of a mess. And they basically said, look, we can't manufacture what we want on the staffing that we have. It just wasn't possible. And then they went through a second wave of lockdown, and I was like, right, okay, we're in trouble now. I'd ran out of stock by that point of the version 1. I had nothing to sell. I had a version 2 that was just sat on a production line. Then we went into lockdown shortly after that, and I was like, right, okay, this might be the end for this project.
I remember you saying.
Yeah, it was like you do something now to try and solve things, leave it or write it out and just see what happens, or just collapse entirely. And I was like, I don't think I like any of these options.
Yeah.
So basically what I did, I basically just put it on pre-order. And I said to people, look, this is the situation. It is coming, but you can pre-order it now at a lower price to secure that price. And you can be one of the first to receive it when it's actually released. And I kind of left it at that in terms of like product development. And I moved over to creating an online course that was about the techniques and about the science to kind of bridge that gap initially. I think in the end, the factory didn't even come back online fully until like mid-April, I think it was. Then I was like, right, how quickly can we do this? And so we blasted through production. May was still a bit of a troublesome time. And then I think I finally got them sometime in June. And then I was relatively at ease. There are still problems, but relatively at ease.
So back up a moment, because actually
I know, it's a lot.
So much to
that's
ask
a lot of
about
stuff,
this.
and also you've glossed over certain things which I really think need to be lifted out and examined. Which is, first of all, you designed something.
Yeah, you're a psychology student.
Sure.
You've been working in the arts. Now, what you've gone into is manufacturing. I mean, how does one make that step? Because,
That's
frankly,
huge.
as someone working in the arts, it's quite terrifying.
So first of all, you designed something. You then found a manufacturer, which is another big step, and got it manufactured, and you had to go through the whole process. And I also want to know from you, just in passing, what the design was and why you made it, because there are certain things about that straw that are really special.
So that's what came out of the research and development phase.
Yeah.
Okay.
Yeah.
Cool.
Okay. Oh, to unpack that. So the design stuff, when I was at uni, actually, I had a crazy medical experience and there was lots of stuff going on. I had to take like 2.5 years deferral of study because I was in hospital for a bit. And throughout that time, the surgeries and the interventions I received were almost archaic. The technologies and the interventions hadn't really changed much relatively since like the 80s. And I kind of almost straight away started thinking, okay, how do I try and make my experiences of this better? And I got in contact with the engineering department at my uni. And I said, look, I'm a psych student. I'm not an engineering student, but I need help. Can you help me? And they just welcomed me with open arms. And it was just the most wonderful thing. And it was incredible. They gave me access to SolidWorks, which is a CAD software, so 3D design software on the computer. They gave me access to their industrial size, like 3D printers, literally the size of the room that I'm in currently. It is mad. And a friend of mine who lives in Sweden is an engineer, and we spent literally every evening for like 6 to 8 months on Skype together, him teaching me how to use SolidWorks. And so I designed these kind of medical devices and components and attachments to try and solve the problem that I had at the time and still do have. And I kind of left it at that because then I went back to studying and I was like, okay, this is manageable. This is fine now. I want to complete my degree. Then obviously moving forward from that, I encountered this problem in the singing world in terms of, straws not being, or rather teachers using straws, the same straw for everybody, as opposed to being specific and generalizing to the person they're working with. And I said, okay, right, I want to understand this a bit more. I want to know what's going on here so I can use the skills that I had learnt to redesign and redevelop essentially the straw, but for the voice.
Yes.
And I'll fully admit, I did not do this completely by myself. Another friend of mine is an engineer and we kind of collaborated a little bit. I brought the knowledge of the voice and the theoretical understanding, and he brought the technical know-how to, create these beautiful design manufacturing schematics for a factory to understand and go, okay, this thing that was in somebody's head, I know how to reproduce this. And so that's how we collaborated on that. But yeah, it was just a function of understanding what needed to have happened as air is moving through a tube, and how to modify and adapt that such that we create an environment that we want for the voice, as opposed to it being an environment that we're just given by virtue of the straw that we happen to pick up.
So you created something that is extendable and changeable
Yes.
and made of metal.
Yes.
And
Why
there
the
was-
made of metal
Yes,
thing?
a specific reason. Yeah.
So obviously teachers, vocalists, if we're doing these kind of interventions, we're chugging through a lot of plastic or a lot of paper. And it's not sustainable for the environment. Fortunately, in the UK at the moment, we have banned disposable plastic straws, which is great.
That's very recent, though,
It
isn't
is a couple of
Very
weeks
recent,
ago.
very recent.
Yeah.
Yeah. So, you know, it was a matter of, I don't want our industry to contribute to this enormous amount of plastic waste. I think it was like 4 million plastic straws or something per year that finds its way into the ocean. And there was a better solution. That solution for me and the product that I want to develop was stainless steel. It's food safe. It's relatively cheap to use. It's very easy to form and mold and manipulate into all these different kind of shapes and structures that we need for the device that I wanted. And it doesn't really damage the environment much. Like, you can recycle it. You can just melt that down and bring something new from its molten state if you wanted. So it was a very versatile material that I felt had less of a environmental impact than plastic or paper, whilst providing greater benefits to the singer.
And completely usable, that's the point.
Yeah, it's
Sure.
totally usable. I mean, and hence the hashtag one singer, one straw,
Yeah.
which is great. And I mean, you could use it to stir your tea or your cocktail.
I
really want
I
to.
cannot recommend that.
I guess so long as it's your own. Yeah. Ooh,
Amazing.
there was something else I wanted to say about. Yeah. Tell us about commissioning work from work abroad. You know, you have so much courage. This is the thing that I'm picking up. If there's a need, you're not going to mess around. You are going to meet that need. You are not going to take no for an answer. And I think that is one of the things that inspires, you know, enables creation, doesn't it? That it's like you said, I didn't like any of the options I was given.
Yes.
So I looked for another one.
And also, I'm going to make it work.
Yeah.
Yeah, that was actually something from that my dad said to me before he passed away. Is if you have an idea, if you have a vision, if you have something that you believe in, don't hold back. Don't. If somebody tells you no, if somebody is blocking you, tell them no back. Like, don't put anything in your way that's going to prevent you from getting to where you want to be, and based on that belief. And it was very much it has to come from a passion, as opposed to, you know, I'm just doing it because I want to make money or whatever. And so that was, I think, my driving factor is I believe in this, and I really believe in this, and I want to see this help people and make the world a little bit of a better place at the same time. But don't get me wrong, manufacturing and commissioning that is terrifying. At this point, so my dad runs his own, well, had a company that basically commissioned these kind of things from abroad all the time and for resale in the UK. And like, when he passed away, I was like, okay, I now do not have anybody that I can just go, how do I do that when I can't even go over to the factory and like see that they're actually who they say they are. And so a lot of it, I think, was a leap of faith. The one thing I will absolutely say to anybody considering it, put your money in an escrow account and don't let anybody have anything up front.
Yeah.
So basically, I sourced out a variety of different manufacturers. I spoke to a lot of different people who were manufacturing similar things. By similar, I mean out of stainless steel. And I narrowed it. The company that I ended up going with actually manufacture stainless steel surgical instruments. So like scissors and forceps and scalpels and all this kind of stuff. Because it seemed more appropriate, if we're using this as an intervention for singing, we need to put it inside our mouth. They at least had some idea of the safety protocols in place that need to be there to make sure that there's no cross contaminants and things like that. And yeah, I suppose I might have been a little bit hot-headed in that I kind of just said, yeah, this is what I want to do. Can you do it? And they were like, yeah, we can do it. Here's some samples of it. And so I basically sent them technical drawings. They sent me some samples and I was like, that looks good. Here's my money. I don't advise anybody do that. What I advise is that you get samples from a range of different manufacturers as opposed to just one. And, really test the waters. Get a translator if you do not speak the native language, because there are inevitably going to be communication issues, which I encountered. And just be really mindful that what you provide them in terms of your technical drawings or ideas need to be protected. Protected both in the form of non-disclosure agreements, I think are absolutely vital. But when you're talking about things that are outside the UK or US or EU, you need to also include an NNNA agreement, or the A is the agreement. So non-disclosure, non-circumvention, and non-something, which basically means, sure, if they sign a non-disclosure agreement, their laws, there's nothing to prevent them copying that device and selling it themselves, even if they haven't disclosed your confidential information. So get all those agreements in place, and if it's a really good idea and you think you've really innovated something, patent it, and patent it as soon as you possibly can. And so I did all of those things in the wrong order. I did them relatively in the right order, I think, for the version 2 at least. But now what I've moved to is I have an on-the-ground agent who lives in country, who is able to, like, we WhatsApp like all the time. We just send voice messages to each other. And she basically goes around, sources all of the manufacturing partners, because we've expanded a bit, and so there's not just one, there's like multiple that we need to communicate with. And so she does all of that groundwork for me, and so it eliminates the need for like a translator, because she is a translator. It eliminates the need for me having to contact individual manufacturers, because she is that person. So if you are considering manufacturing anything, collaborate with somebody who knows the environment, who knows the region, and who knows the people.
I think
And the culture.
and the culture.
And the culture, absolutely.
I think it's really interesting, just because in the sort of popular mind world, somebody has an idea, they create something and they sell it, and that's it. Good for them. And what you realise is when you're doing something like this, which involves manufacture, I mean, we're authors, we create books, but there's still a whole load of stuff that goes on behind the scenes. Once you start doing manufacturing, particularly when you're manufacturing in something like metal, there are so many processes to go through, and also so many protections to put in place, because what you're doing is so special. And people are going to want it. People are going to want to copy it. People are going to want to take it. They're going to want to do all sorts of things, because unfortunately that's human nature. So there's so much behind the scenes stuff that people don't actually recognise even exists.
Oh yeah, and it's also one of those things that people don't necessarily realize exist, but also people don't also realize that there is a cost associated with those things. And so it's kind of like, oh, it's so cool, you've created this, but it's a little pricey, or there's why didn't you do it this way, or would you consider doing another color, for instance? And it's just like, I mean, yeah, I would love to make it cheaper, I would love to do other colors, I would love to have this kind of customizability, but new colors cost money, new this costs money. So everything, it's all about trying to find that balance between, is it necessary, or is it just, does it provide a functional purpose, or is it just for looks, basically? And I kind of settled on the colouring, and I settled on this as kind of a middle ground, but the core is its functional purpose.
Yes.
Yeah. I think what's interesting about this is that now we're almost talking entrepreneurship, aren't we? Because you've created something, it's a very, very clear brand. And during the time when you couldn't sell because you were waiting for the next batch of manufacturing, what you very sensibly did, albeit maybe it was out of desperation, was you started to educate your potential audience, potential market.
I also want to talk about the ebook that you wrote.
Yeah.
Because that came out before version 2, didn't it? Right.
It did,
so there is a free ebook available that you wrote.
Yes.
And it's got some nice science in it.
It does.
Yeah, so actually, and I guess thank you for endorsing that in the way that you did, because you wrote Gillian, you wrote the foreword for it.
Yeah.
And the it's changing now. So yes, I initially wrote the ebook in sort of concert with the version 1, and it presented the science and some practical techniques and exercises based on my understanding at the time. Since I have been evolving the version 2, I've done a lot more in-depth analysis in terms of the physics and actually what's going on within these kind of devices and tubes and whatever kind of tubular device it is. And from that, there is a lot more science to be spoken about, and it's about how do I make that both really detailed and really interesting for the people that are really keen on the science, but also how do I make that super accessible for the people that aren't.
Yes.
And the ebook at the moment is evolving, so I'm rewriting aspects of it to update it to based on what I know now. I'm updating it based on the simulations and the data that I've gathered through my work, and I'm hoping to offer 2 versions of it: a hard copy version, and then still the free ebook version if people would like that as an option. Because everybody loves a hard copy.
Oh, absolutely. There's some things here that you've kind of touched on, and obviously, I mean, we're not asking you to offer a training course here, but the sort of questions that I have in my mind, I can remember a couple of pan-European voice conferences ago, there was a whole presentation on SOVT, and Ingo Tietze presented his work on why he thinks it works so well and the impact on the vocal folds. And there was a debate about whether length matters. So Ingo Tietze was in the camp where actually the length isn't important. The LaxVox people were not in that camp, and they said that they felt length did matter. And, other questions I have in my mind, LaxVox tends, I think, to use a silicone tube or a plastic tube. And I know that when I blow into my Dr. Vox, which is made of silicone, it's a very different sensation from blowing down one of my biodegradable straws or your metal straw. So a question in my mind is not only about length and width, but what the device is made of and whether or not that makes an impact.
It absolutely does. And so this has really been the fundamental kind of questions underpinning the work that I'm doing at the moment in terms of my computer simulations and mathematical models of what's going on in these devices. And first of all, length does matter in these in this topic. Maybe that is controversial to some people, but if we look at the physics of what's going on, what we're talking about, the fundamental underpinning of how you calculate the resistance is you take the input resistance or the input pressure and output pressure, and you find the difference, or you find the drop between them. And so you say that the tube has a pressure drop of whatever the value is, and that is your resistance value. And so when you're thinking about it in this way, if you have a longer tube, sure, if you have a longer tube with a fixed diameter, the pressure drop isn't going to be that much. And so in that situation, I appreciate that the argument might be that length doesn't matter because you're purely focusing on the aperture.
Okay.
When you have a tube that does something else, either putting it in water, for instance, or having, expansions and contractions like our tube does, then length does become really important because across that length, we're looking at how the tube starts in terms of diameter and how it ends. If the starting diameter is larger than the ending diameter, then you're going to have a greater pressure drop because you have a greater pressure,
yes.
significantly greater pressure at one end and a lower pressure at the other end. You get a greater pressure drop as a result, and you get increased resistance as a result. So length, I think, does matter just depending on what device and what specifically you're trying to target. In terms of material properties, though, which is kind of interesting, I don't think it matters too much. It depends on the airflow. Stainless steel is a very smooth material. And so, if you're looking at the micro level, the impurities in the surface finish are just tiny. If you're looking at something like biodegradable paper, you've got fibers and things that kind of jut out on the microscopic level, which will impact the airflow across the boundary layers. And so you might get some more turbulence in that airflow, which will increase the resistance. Silicon materials will do the same, but then obviously everything is now in accordance to the diameter. Typically, the silicon tubes that we use are wider in diameter. And so there is less interaction of the air across the boundary because more of it is just passing through the center.
It's the percentage, isn't it?
That makes sense.
Yeah.
Yes.
Yeah.
Ooh,
Percentage of width.
good. Well, that
To
was
turbulence.
an exciting answer. Okay. You know what? I think we should take a little break here. We've already had so much content. Why don't we split the podcast in two and deal with the fascinating questions that are coming up, our wonderful AMAs, in the next half? Because basically there's more to be shared, isn't there?
Okay, so this is part one, and this deals with the science behind SOVT and also Oren's background. And part two coming up will be the Ask Me Anything questions, and we have some great questions lined up.
To be continued.
This is A Voice, a podcast with Dr. Gillian Kayes and Jeremy Fisher.